Given A and B, find B and C. Okay, that's the problem we are faced. Given the incoming amplitudes, find the outgoing amplitudes. That's the problem of direct scattering. Given A and B, K and B, find B and C. Given the incoming energy and the amplitudes and the potential, find the scattered amplitudes. Okay. Now, because the Schrodinger equation is linear, the relation between the incoming amplitudes and the outgoing amplitudes is a linear relation. In fact, we have already found the relation in a specific problem. You would have noticed that we have a pair of linear equations. But that's true in general. Schrodinger equation is linear. Schrodinger eigenvalue problem. So this is time independent. Linear. So BC are linearly related to AD. There is a transformation, a matrix that maps the incoming amplitudes to the outgoing amplitudes. That is, BC is equal to some S times AD, where S is a 2x2 matrix. Okay, that's what it means to be linearly related.
It's always 2x2 because our differential equations are of.
It is 2x2 because we are in one dimension. Okay? That is, the basis for the space of incoming states is two-dimensional. In this case, in one dimension. If you are in two dimensions, you can have incoming waves from all angular directions. Okay? You'll have A1, A2, A3, A4, A5, A5. Then, in place of A and D, you'll have an infinite column vector of incoming amplitudes parametrized by the angle. And you'll have similarly scattered amplitudes parametrized by angle. In that case, there will not be just two, there will be infinitely many. S matrix will be infinite dimensional. So S matrix is, even though Schrodinger equation is second order, even in two dimensions. So it's really 2x2 matrix only because we are in two dimensions, in one dimension. So that's a very good question. But here is the simplest case where we can understand a lot about the S matrix.
Some kind of rotation.
Yes, it's a lot like a rotation, except it's not a rotation of the plane, it is the rotation of a two-dimensional complex plane.
B and C can be complex.
Right, A and D can be complex, B and C can be complex. But the idea that it's a rotation is a very good idea. The precise statement of that idea is, what's a rotation in a complex vector space called?
It's a rotation complex.
What is the name given to a rotation in a complex vector space? Unitary transformation. As is a 2x2 matrix, will show it is a complex, I mean, to use the language we have used, complex rotation, more precisely, a unitary transformation. Okay, by unitary I mean SS diagonal is equal to identity, S diagonals.
You know that the linearly related for position of linearly related BC matrix is linearly.
No, BC is a pair of complex numbers. It's a 2x2 matrix, AB. So if I write this out to say that B is equal to S11A plus S12B, you will agree with me this is a linear relation between B and A and D. Similarly, C is equal to S21A plus S22. This is what we mean by linear relation. We are written in a compact notation. So, all the information in T and R in S matrix. The S matrix has information about reflection and transmission, amplitudes as well as coefficient. Let us see why. So you understand that it's a 2 by 2 matrix. Unitarity we will show separately. Now to understand a matrix, we have to understand its columns. Okay. Let us see what the first column. What physical problem does the first column of S represent? Notice how will you pick out the first column? See, A and D are in our control. B and C are outputs. A and D are in our control. For what choice of A and D can I pick out the first column? One zero. Very good. If you take A equal to 1 and B equal to 0 and multiply this out, okay? You notice output will be S11, S21. But by definition that is B comma C. So, what's the physical meaning? What is A equal to 1, B equal to 0? It's a standard scattering problem. Scattering of unit amplitude wave from the left and nothing from the right. So the standard scattering problem of unit amplitude wave from minus infinity gives the first column of S. This is the problem we solved previously, right? Just take A equal to 1, B equal to 0. That's a standard scattering problem.